We are going to talk about how to create geographic heat map in RStudio. A geographic heat map uses color gradients to show data across regions, highlighting spatial patterns and trends. It enables easy comparisons of locations, making it valuable for displaying matrices like population density, disease spread, economic indicator, and weather conditions, aiding in regional analysis and decision-making. The datasets we use provides a 2022 age distribution across China's 31 provinces. It includes proportions for 3 age groups, 14 and under, 15 to 64, and 65 and above. This analysis focuses on the population aged 65 above to understand the aging distribution across mainland China. Map data is essential for geographic heat map. It provides the structure for accurate data display. It also plays a role as the base layer for the heat map. Map data defines the locations, shapes, and boundaries of geographic features like country and cities. We'll use publicly available map data for China from Cargo in this analysis. We use the GADM map with ggplot2 and geom-SF in R to create a heat map. GADM offers high-resolution administrative boundary data worldwide, ideal for detailed spatial analysis. Its compatibility with R and detail structure make it valuable for mapping fields like public health and urban planning. The cargo data mapping data includes GADM data converted to GeoJSON, ideal for interactive maps. GeoJSON is a lightweight JSON-based format for geographic data, represents features like points and polygons. It's compatible with web applications and allows for easy data integration. We then load the population data sets for China's 31 provinces, rename columns of clarities, and also remove the national average rows. This setup provides age distribution ratio for each province, preparing the data for integration with map data to visualize age distribution across China. We prepare to merge population data with geographic data by creating a province map data frame that assigns each province a unique map ID from 1 to 31. This ID links each province to each spatial boundary in the China map GeoJSON shapefile. After loading China map, we perform a left drawing to add map ID to the population data, setting it up for geographic visualization. To ensure matching province name between datasets, we use the recall function to rename certain province in China map, such as changing name Mongol to Inner Mongolia. We then rename name 1 to province to match the population data for merging. Finally, we merge China map with population data on province, creating China population map data with both geographic boundaries and population data ready for visualization. The merged dataset shows each Chinese province with geographic and demographic data. Key columns include province age population ratio and map ID, linking with each province to its map boundary. The geometry column hosts multi-polygon coordinates defining each province shape, making the dataset ready for heat map visualization. We use GeoSF and ggplot2 to create a geographic heat map from China population map, mapping age 65 and older to the field aesthetic. The map visually constructs regions with higher elder population with orange and lower one with purple, useful for policy insights. We can change the color scheme in the scale fill gradients to allow easy customization of the heat map. Here we can set the gradients from the light blue to the dark red for a more striking effect. After adjustments, using light blue and dark blue improves the visualized contrast for displaying population distribution. We can also adjust the color contrast in the heat map. We use the scale fill gradient with a color gradient from light blue to dark blue, then add a settings limits from 1 to 40 to emphasize the range of elder population percentage from 1% to 50%. These adjustments within the range of the color, which can make the contrast less obvious than before. We can also do inversely by narrow the range for stronger contrast. We can also add labels for the top 5 provinces with the highest elder populations ratio using geotext repel from the GG repel. We position labels without overlap. The labels and lines are still in pink for visibility. This additional highlights key areas with significant elder populations, enhancing the map's readability. So here's the output. On this graph, we can see the top provinces with the high elder rate is Liaoning, Shanghai, Jiangsu, Sichuan, and Chongqing provinces. And we can also clearly see where those provinces located. Okay, and here is some references.